Okay, guys, we're moving on to Chapter 2. Some of you are going to be retaking Chapter 1's test. It's okay. We are going to move on with new material or newer material in Chapter 2. Now understand, Chapter 2 still requires you to use the same things you did in Chapter 1. And we're going to be referencing the assignment to 1, and that's going to be posted on my Moodle page, so you can pause now, print it out, and then follow along, and you can put your notes right on that assignment. All right, so here we go. We start doing the assignment, and I'm going to do it as if I was a student. Hopefully, you are paying attention and moving along with me. It says, the E&W Light Company charges their customers 14 cents per kilowatt hour. 14 cents per kilowatt hour. So I saw that word per. So I know what I'm supposed to do. $0.14 per kilowatt hour. Okay? So I know I'm supposed to circle per. What's in front is my dependent, yes. Now this is always happening, that's why we want to put it like this. If we can say per, or an, or each, or even use the word depends. The 14 cents, the amount of money, depends on how long it runs. Okay, so there we are. And then this would be the independent. Okay, so we still have to clarify that. Dependent, independent. And we write it on our chart. We know that we're going to have to do a chart eventually. Now this isn't done right away. Hopefully you're following along in the notes. But you know that you'll write your independent down here. You are correct. Because your independent is your X. And you'll write your dependent over here. And your dependent is your Y. Okay, that's on the next page. It's not on this one. But knowing that this is what's coming. And you've seen this in the software. And we know if we don't spend any money, or excuse me, if we don't use any electricity, we won't spend any money. So that means we have to know we're starting at 0, 0. Why? Because you don't spend any money if you don't use any electricity. All right. So let's say if we were going to put these in a chart. Hopefully you know that when you put them in a table, you're supposed to put them in the table the same way you would think about them. So we think that independent is the X, and X always comes first. Now this is where some people have a problem, because in the software it allows you to put the X in either one of these columns. Well, that's going to cause you an issue later. You want to get used to putting the X in the first column. If you put the X as the expression, you won't have an issue in the first column. But the X is our expression, and the units and quantity would be electricity usage or monthly electricity usage. How much electricity do we use? And that's measured in kilowatt hours. Okay? So you don't even have to know what a kilowatt hour is, but you do know that the quantity would be monthly electricity usage. Now I'm using an abbreviation to see how many of you actually write it out. Because you're not supposed to be writing what I write. You write what I'm talking about. So this would be monthly electricity usage. And this table's already done for you if you've already printed out the assignment. Okay? So this would be your independent. You'd have it labeled. This is your dependent. Again, I'm using abbreviations. And this is my monthly electric usage. It's in kilowatt hours. You write out kilowatt hours. And then this is the cost. And this is in dollars. And then you would go through and figure out the monthly cost. Well, the nice part is they give you the kilowatt hours. So now you're going to take the kilowatt hours and you're going to multiply those by what? hopefully you know you would multiply it by 0.14. For every kilowatt hour, it's going to cost you 14 cents. So if I multiply 14 cents times the kilowatt hour, I'll figure out how much it is. So here's my expression for my independent, and then the math expression for here. Now in the software, all you have to do is put in the number. So for example, in this cell, everybody knows that we're dealing with cells. It's like an Excel program. You would put in 0.14, and then you'd put parentheses, and you'd put 1,000. And it would write in the answer for you, because the first thing they gave you here was 1,000. So in the software, if you plug it in, it gives you the answer. You don't have to use a calculator. It will do it for you. Okay? The only thing it doesn't do is work backwards. That's when you have to use your algebra skills or pre-algebra skills and use your one-step and two-step problem solving. And that's when you're going to use the solver. The solver is what you use in the Carnegie Cognitive Tutor. All right, so you fill out the rest of that table. You have all the numbers there. You're going to have to do the math this time because obviously you're not on the Cognitive Tutor. You're going to type it into your calculator and change the amounts and keep getting amounts there. Okay, and then I will check it on Monday. Okay, so the next thing you're going to do then is we're going to calculate the rate of change. Right? So how do we calculate rate of change? Well, rate of change is from one to the other, from one to the other. And many of you remember rate of change as what did we go from to, or some of you knew it as slope. These are all the same. Okay. So you take these two numbers and subtract them. So in this case it was 0 minus, and this is going to be, hopefully you know it's 140, right? And these two numbers, which would be 0 and 1,000. When you subtract those, you get and you should know that two negatives make a positive. Now this is what your calculator won't do. But you have to know that you can reduce this. This is 14 over 100. And then you reduce it again, and it becomes 7 over 50. This is the math you should already know how to do. This is called rate of change. The dependence changing and the independence changing. Okay? And you can go right down the list. So you go 0 minus 140 on one side, like this. I would tell you to draw it like this. And then you do this on the other side. So this was negative 1,000. This was negative 140. Then you do the next one. Now you have the chart. Hopefully you've either printed it out or you can pull it up on your screen and just copy the chart. That's fine too. You don't need to copy all the words or the problem, but copy the chart because you're going to need all that. And you should notice that all of these remain the same. They should all be negative 1,000, negative 1,000. Well, we'll let you figure it out. But they should be close. We'll see if they're all the same. C is where we do the math work. So you can do the math work here. You don't have to answer C because the C says calculate, and we're doing all the calculations on the chart. So you can do all the calculations on that first chart. Okay? This could be your calculations. And you should notice that they always remain to this. By the time you're done with all the math, as you keep going, you should consistently end up with 7/50. Okay? Now, if you do the calculator work and you can't reduce, you can also just divide this, and you'll end up with 0.14. You should keep dividing. Like if you do 7 divided by 50, you get 0.14. If you can't remember how to reduce, you can take the original numbers and just divide them and write down what the answer is. And it should remain the same. Correct. So when we talk about our function, this would be our expression. This is our expression. So we have an expression for the x, which is always x, always. Expression for the problem, which is our y equals da-da-da-da. And if I want to write this in function notation, instead of having y equals 0.14x, if I do it in function notation, who can tell me what I would write? Correct. F of x equals 0.14x. Okay, function notation. And then we could go ahead and graph all of these points. And that's what they give you. They give you a graph, and you graph all those points, and you can draw a line. All right? So the slope of the graph and the rate of change are the same. And this is what we're going to be doing in all of this section. Being able to create an equation, plug numbers in, solve, and graph points. All right? Thank you very much. Look forward to seeing you on Monday. Prepared for this. We'll do 2-2 and 2-3. 2-2 will be due Wednesday. 2-3 will be due Friday. Have a good weekend.